Hello, I'm Lee Frelich, Director of the University of Minnesota Center for Forest Ecology, and I have prepared this short presentation on the science and ecology of climate change. So, greenhouse gases like carbon dioxide trap heat in the atmosphere. They act like a blanket, and they especially retain heat close to the surface of the Earth. We actually have a natural greenhouse effect of about 58 degrees Fahrenheit. That's how much warmer the Earth would be than if there was no greenhouse effect at all. And if we continue to add carbon dioxide to the atmosphere, we could enhance that natural greenhouse effect by 10 or 20%, or perhaps 6 to 12 degrees Fahrenheit, depending on the emission scenario as we go forward. We've been measuring carbon dioxide increases since about 1957, and it turns out that as time goes on, the slope or the steepness of the increase in carbon dioxide concentration of the atmosphere has been going up, and this has been proportional to the human population on the planet and the amount of fossil fuel use that emits CO2 to the atmosphere, as well as deforestation, which is another major source of carbon dioxide emissions to the atmosphere. We've known for a long time that carbon dioxide is a greenhouse gas. For example, Fourier was the first to discover in the 1820s that carbon dioxide is a gas that can retain heat in the atmosphere. A few decades later, Tyndall showed that carbon dioxide played a role in the changing climate of the Earth. And finally, in the late 1800s, the Swedish scientist Arrhenius had the first projections for how much the mean temperature of the Earth would increase if we doubled CO2. And Arrhenius was the first one to realize that if humans are burning fossil fuels and increasing the CO2 content of the atmosphere, and increasing CO2 can warm the planet, therefore people can warm the planet. So he's the real father of global warming, even though that's not what he called it at the time. So we have a massive 200-year body of scientific evidence that climate responds to the laws of physics, and it doesn't respond to people's opinions or beliefs. Hans Suess also played an important part in climate science by showing in the 1950s that excess carbon dioxide showing up in the atmosphere was coming from fossil fuel burning, because that CO2 has a unique isotopic fingerprint. This CO2 was not coming from volcanoes or from the oceans or other sources. In addition, if we look at the rising temperature in recent decades, this shows from the 1950s up through about 2015. The rising temperature, as indicated by instrumental records at weather stations around the world in the gray line, is going up in proportion to the carbon dioxide content in the atmosphere, which is the blue line. It's interesting that solar activity, shown in the yellow line, has not contributed to this increase. If you look at the long-term trend, it's pretty much flat. And if you look at the cycles, which are related to sunspots, approximately an 11-year cycle, the most recent peak is actually lower than other peaks. So the sun has been relatively cold, and yet we set a new record for global temperatures in 2015. If we look at a longer term, we have good reconstructions of the climate based on paleoecological evidence from CO2 trapped in ice cores and responses of trees and many other forms of analysis that allow us to reconstruct the climate over thousands of years. We know that about 20,000 years ago we started to come out of a glacial period. There was rapid warming. The peak of the interglacial cycle was between 6,000 and 8,000 years ago. We refer to that as the mid-Holocene warm period, and in the last 5,000 years there's been a natural cooling trend. If we look at the red line on the very right side of this graph, that's the last several decades with a very rapid rise in temperature, which has now eclipsed the peak of the mid-Holocene warm spell, which would have been 6,000 or 7,000 years ago. And here's a map of world temperatures for all of the year 2015, and it shows whether temperatures were cooler than average or warmer than average locally for each of the grid squares here, and much of the world had the record warmest temperatures. There's a lot more red on this map, which means warmer than average locally, than there is blue, which occupies a tiny proportion. So what can we expect in the future? Well, that depends on our choices for the amount of carbon dioxide that we emit. With a business as usual scenario, it could warm up as much as 4 to 6 degrees Celsius, which would be 7 or 8 to as much as 11 or 12 degrees Fahrenheit, but with reductions in the emissions of CO2, it may be only as much as 2 degrees Celsius, which is only about 4 degrees Fahrenheit. And this would make a huge difference for quality of life and the economy and the biodiversity of the planet in the future. So what are some of the really big impacts of a warming climate? Well, one is melting of ice sheets in Greenland and Antarctica, especially the West Antarctica ice sheet. With the 1 degree of Celsius warming we've already had, we expect a rise in sea level of 6 to 9 meters or 20 to 30 feet. With a much bigger rise in temperature, we expect much bigger rises in sea level. Could easily be 30, 40, 50 feet or even 100 feet in future centuries. And this would have devastating impacts as we realize that all the most valuable real estate in the world, which is oceanfront, is actually worthless because it's going to be underwater, and that we're going to lose cities like Washington, D.C. and Miami and New Orleans, I guess, for a second time, and then cities like London and Copenhagen and so on. So the less temperature rise, which would correspond to reduced CO2 emissions, the less the impact of sea level rise. Also, a rising CO2 content in the atmosphere affects the acidity of the ocean because carbon dioxide reacts with water to form carbonic acid, and as the level of CO2 rises, it causes the pH, or the level of acidity of the ocean, to go, well, the pH would go down, but the acidity would go up. This would affect a lot of species that live in the ocean that have shells that are made out of calcium carbonate, because when the water is more acidic, it's hard to form those shells. And this would have implications for the base of the food chain in the ocean, which is based on some plankton that form shells, as well as coral reefs that are built of calcium carbonate. So a high level of acidification caused by high CO2 levels could be really devastating to life in the ocean, which would have huge impacts on the economy and quality of life for everyone on the planet. What do we expect locally, though? Since I'm the director of the Center for Forest Ecology at the University of Minnesota, what might happen in the forests of Minnesota. So I'm going to talk about our iconic natural area in Minnesota, the Boundary Waters Canoe Area Wilderness. Today it has boreal forest, which is cold climate northern forest, made out of pine, spruce, fir, birch, and aspen. It's one of the 3 biomes in Minnesota. So you can see here the area of interest is just to the northwest of Lake Superior, and it's part of the boreal forest that extends from Alaska across Canada all the way to the Atlantic Ocean, which dips just a bit into northern Minnesota. Temperate forests of oak and maple lie to the south and prairies, which are shown here in white, lie to the south and west. So here's a map of Minnesota. The question here, maple, spruce, or savanna. Spruce would represent the boreal forest, which is the dark green. Maple would represent the temperate forest, which also has a lot of oak in it, which is the light green, and savanna or grasslands would represent the yellowish to beige color in the west and southern part of the state. Because we lie in this unique place in the world where these three biomes come together, and these biomes are dependent on climate, a changing climate could change the look of Minnesota quite dramatically. So here's one projection for summer temperature in the future. This is June, July, and August mean temperature projection from now to the end of the century with a high emission scenario in the upper, showing that by the end of the century it could be 13 degrees Fahrenheit warmer during the summer, or a reduced emission scenario if the Paris Agreement from last year were to be successful, where we would only warm up about 5 degrees Fahrenheit. The upper scenario, the business as usual, 13 degrees, that would make Minneapolis equal to about Manhattan, Kansas, whereas the low emission scenario would warm us up about equal to what Des Moines, Iowa is today. What would this do to our forests? Well, if you look at this map here, it shows the abundance of balsam fir. The red colors show where there's a high abundance. That's our favorite Christmas tree. It's a component of the boreal forest, and with a business as usual or high scenario for warming, that would exit the state, along with white spruce, black spruce, the boreal, jack pine, and red pine, and greatly reduced abundance of paper birch and aspen. What about the relationship between the boreal forest, and which is the conifers of spruce and fir, and the temperate forest of maple and oak? Well, that also depends on summer temperature. And this graph shows relationships that we have been able to construct between summer temperature and the growth of these species, balsam fir and white spruce, which are major components of the boreal forest, and red and sugar maple. And you'll notice there's a tipping point in the middle where all these species grow about equally, and therefore they could grow side by side in mixed forests. Whereas with cooler summer temperatures, the fir and the spruce grow more, and with warmer summer temperatures, the maple grows more. That tipping point of 18 Celsius is right around 65 or 66 degrees Fahrenheit. So look at a place like Ely, which is right next to the boundary waters from 1960 to 1990, is cool enough that fir and spruce are clearly growing more than maple. At this point, they're close to the tipping point, and as it continues to warm in the future, the balance will be thrown to red maple and sugar maple, which will, along with oaks, will gradually be able to replace the boreal forest of spruce. And here's a picture showing a place in northern Wisconsin, Newport State Park, and there's a sugar maple sapling on the right, mixed right in with balsam fir saplings on the left. And 30 years ago, when I was working at this site, there was no sugar maple in this forest at all, so the little bit of summer warming we've had has allowed maple to start to invade and grow almost as fast as the spruce and fir. Looking across the entire region, our studies indicate that the temperate tree species are invading boreal forests, but have not had time to replace the boreal forest yet, and it's not warm enough yet to kill the boreal forest. So the mixed forest, or the ecotone, where the two forest types are mixed together, is becoming wider at this point. In addition, I mentioned earlier, we have the prairie in Minnesota. On the map on the left, you see the prairie versus the forest. It runs from northwest to southeast across the state. And it turns out that that's related to the precipitation minus evapotranspiration balance. In other words, there's evaporation of water plus transpiration by trees and other vegetation. If there's more rainfall than there is transpiration and evaporation. Then we're in the green and the blue areas on the right-hand map, and those are the areas that support forest. The boundary waters is way in the northeastern corner of the state where it's blue, where there's a big surplus of precipitation. If there's more evaporation than precipitation, there's a negative water balance, and then we get prairie. And so where do we expect this zero balance point where precipitation and evaporation are equal? Where do we expect it to move? The black line shows where it is now, and on this map that the heavy black line shows on a more continental extent where that zero balance is, and the small arrow shows where it would move. For a business as usual scenario, it would move about 300 miles and it would take it to about Thunder Bay, Ontario. The yellow star there shows the location of the boundary waters Canoe Area Wilderness, which would be right at the prairie forest border at the end of the century for a business as usual CO2 emissions scenario. In addition, increasing drought frequency, insect infestations due to the lack of extreme cold in the winter that keeps insects under control, and more windstorms and fires could accompany climate change and help cause transition from either boreal to temperate forest or from boreal forest directly to grassland or savanna to happen even more quickly. So here's the boreal forest right now. This is the north shore of Lake Superior in Minnesota, a very boreal landscape, lots of conifers and birch trees. What might it look like? Well, we found some climate analogs, the places that right now have the climate that represents the future of the boundary waters. So the blue star shows the boundary waters today, and the orange star shows what the climate might be by the middle to the end of the century. And it turns out there are some natural areas near that orange star that we can look at to see what the vegetation is like in that type of climate, and they happen to have the same type of rock and physiography as the boundary waters. So here's the boundary waters today with boreal forest, and here is nice outcrops natural area in southwestern Minnesota. And here's the lake and island, rocky island scenery with a warmer climate. And so we have here oak trees, maybe a few maples in here, some box elder, and a pretty strong prairie element as well. So it's a big change compared to that boreal forest. And along with the change in the biome, of course, would be changes in wildlife, because wildlife depends on certain vegetation for its habitat. So with a warmer climate and the loss of the boreal forest in Minnesota, lynx would be replaced by bobcat, moose would be replaced by deer, and black-backed woodpecker would be replaced by red-bellied woodpecker or other woodpeckers. We could put hundreds of different wildlife species on this slide as examples. I mean, this is just a very small group of species to show, but they represent some of the iconic species of northern Minnesota that would be lost in a warmer climate. So, if you have any questions, you can contact me. My email address is given there. Thank you for listening to this presentation. And again, my name is Frelich. I'm director of the University of Minnesota Center for Forest Ecology, and thank you for listening to this presentation.